reason this machine is such a big deal is that up until now, for all of human history, everything that we know about the cosmos has been from waves of light and particles that just happen to come our way. But it turns out there are other ways to sense our universe. Think about it this way. Imagine that you're in a jungle and you can only see. Think about what you know about what's around you. Now, with this machine, it's like all of a sudden we can suddenly hear. Think about what you know now about what's around you. That's why LIGO was built, to create a way to hear our universe. And with this machine, our hearing is getting better, fast. It's as though a few years ago we could only hear the universe yelling, and now we can hear it murmuring. But when scientists started building this machine back in the 90s, it was thought of as high risk, high reward, because it was all based on a prediction made by Albert Einstein 75 years before. Imagine for a second that two enormous stars, 100 light years away from us, collide. What happens here on Earth? Well, at first, nothing. We don't see it. We don't feel it. But Einstein predicted that massive things warp space and time around them. And that's what we call gravity. So when these two massive stars collide, Einstein said that not only do they produce an explosion of light, but they make ripples that stretch and squeeze space and time. And those ripples move outward like a wave, a gravity wave, a gravitational wave. And Einstein predicted that these gravitational waves travel at the same speed as light. So after 100 years, that light from that collision hits us, and so do these waves. But think about what that means. It implies that everything we know, you, me, the space between us, all of reality as we know it, is getting stretched and squeezed, and we never feel it. But 100 years ago, this was all just a theory, gravitational waves. Most physicists believe that even if Einstein were right, it would be too hard to actually prove. That's because based on Einstein's predictions, this stretch or squeeze would be 10,000 times smaller than the size of a proton. To put that into perspective, trying to measure that is like trying to measure the distance from here to the nearest star 4 light years away and watching that distance change by the width of a human hair. Yeah, that's why we had to build this insane machine.